Hello and welcome to this module on 8051 Assembly Language Programming 1. This comes under Bachelor of Science of Electronics subject. Subject code is ELC 104 and the title of the paper is Microprocessors and Microcontrollers. Myself, I am Sunoj Raikar, Associate Professor at DM's College and Research Center, Asagaon, Goa. In this particular module, we are going to study about the programming languages, the different types of programming languages such as machine language, assembly language, high-level language, assembly level language programming. Then we are going to see the advantages and disadvantages of assembly language, the structure of 8051 assembly language statements, then 8051 microcontroller assembly language directives, and steps for assembling and running a 8051 program. Lastly, we are going to see how to use the Keil environment, that is Keil IDE, for assembling and generating a hex file. After undergoing this module, a student will be able to explain the importance of assembly language used for programming microcontrollers, describe the various steps for assembling and running an 8051 program, explain the various assembler directives of 8051 assembly language program, explain the structure of 8051 assembly language program statements, and finally use Keil IDE for assembling and generating hex file of 8051 program. So what is the programming language? Programming in general means writing a sequence of instructions that are executed by the processor in a particular order to perform a predefined task. Programming also involves debugging and troubleshooting of instructions and instruction sequence to make sure that the desired task is performed. Like any language, programming languages have certain words, grammars and words. The different levels of programming languages. One thing is called as machine language or machine level language. It consists only of ones and zeros, that is a binary language which is only understood by machine. So this is the picture which shows, ones and zeros which are actually understood by the machine. Machine, here I am referring to a microcontroller or a microprocessor. Next comes the assembly level language. Assembly level language consists of some instructions which are called as mnemonics or pseudocodes, and examples are like move, add, mul, and all such things. Then there are high level language which we are very much familiar with, like C language, C++, Java, Python, embedded C. What is assembly language? Assembly language is a programming language used for programming microcontrollers and microprocessors by using the instructions from the instruction set of a respective microcontroller or microprocessor. This means that assembly language is specific to a given processor. It also is a low-level programming language and requires extensive understanding of the architecture of a microcontroller. That means without knowing much about a particular device, a particular microcontroller or a microprocessor, it is rather difficult to program a microcontroller using its assembly language. The 8051 microcontroller assembly language is a combination of English-like words which are called as mnemonics and hexadecimal codes. Assembly level language programming makes use of a software called as assembler to generate machine code. Machine code is a binary file understood by the machine. Machine, here I am referring to microcontroller or a microprocessor. Some of the examples of assemblers are which are used for 8051 microcontroller are ASM51 and A51. Let us see now as we move from machine language towards the high level language, what happens? As we move from the machine language to the high level language, the portability increases. By portability, I mean to say that the machine level language is not so portable. Then flexibility also increases. Then ease of implementation also increases. So as we move from machine level language to high level languages, we can clearly understand that it is very easy to implement the high level language programs and as compared to the machine level language program. On the other hand, if you go to see the other features, as we move from high level language to the machine level language, the speed of execution decreases, the code density decreases, and it becomes more and more machine specific. So here we'll emphasize on the speed of execution and code density. So what we can understand is that though the high level languages are very easy to implement, but they are having a drawback in the sense the speed of execution of the programs written using high level language will be less. Then the code density. Here by code density I mean the amount of packaging of a code that is possible by using high level language. It becomes the code size becomes too much, whereas as we move towards assembly language and machine language, the code size becomes very compact and less. Again, just will highlight the advantages and disadvantages of assembly language. Assembly language, as we have seen, it is more it is memory efficient as it requires less memory, and it is faster in speed as the execution time is less. The disadvantages of assembly language is that it takes a lot of time and effort to write the code for the same, and there is a lack of portability of programs between different computer architectures. Now, in order to write a program for a microcontroller using a high level language, we make use of certain compilers which are called as cross compilers, and the type of language which is most commonly used is C language. So now here we are not going to use directly a C language, but it is very close to C language. It's called as a embedded C language. So that's what I'm referring to high level language here now. So from this diagram we can see that in order to have a machine language derived from a high level language, we'll be making use of a cross C compiler or a embedded C compiler, which is going to convert the high level language into machine level language by following an intermediate step of assembly level language. And finally, the hardware will be able to interact with this particular machine language, which is consisting of a binary file consisting of ones and zeros. Now, there are certain guidelines which must be followed for assembly level programming. The assembly code must be written in uppercase letters, preferably. It doesn't mean that the code written in lowercase will not work. It is not that it is case sensitive, but preferably this should be followed, because for high level language we follow another conventions. So these are the conventions or the guidelines to be followed for writing assembly level code. So assembly code must be written in uppercase letters. The labels must be followed by colon. All symbols and labels must begin with a letter. All commands are typed in lowercase. The last line of the program must be the end directive. The elements of assembly level programming. First, we'll be studying about assembler directives. These are some of the important elements of assembly level language programming. Assembler directives such as org, db, equ, and then we'll be studying about the instruction sets and addressing modes. Addressing modes will be covered in the next module, not here. 8051 microcontroller assembly language directives. So now what are assembly language directives? So these are not the actual instructions to the 8051 microcontroller assembler, even though they are written in the mnemonic field of the program. Assembly language directives are actually instructions to the assembler and directs the assembler program what to do during the process of assembling. The assembly language directives do not have any effect on the contents of the 8051 microcontroller memory except two directives, which are DB and DW directives. These directives are dependent on the assembler program. So let's see the first directive, which is very commonly used in almost all the programs. It is called as ORG or set origin. The meaning of org is set origin. Now, what is the meaning of set origin or org? So, we'll straight away see the program example here. Here, the first instruction which is written is a assembler directive org000h. The meaning of this is that originate the program or start writing the program on the program memory from 0000h onwards. Then of course comes your here in this example itself we'll try to understand what happens. org000h tells the assembler to assemble the statements at 00h onwards. Ljump main. So this is a statement which tells the which is a program instruction to jump to a main. Then org000b, this tells the assembler to assemble the next instruction at a memory starting from 000b onwards. Next, let's see the db directive, which is also called as a define byte. So here we'll straight away go to the program and try to understand these instructions. org000h. First instruction is db10. So db10 is define by 10 decimal and store this particular value at 0000h. Why 000h? Because we have started the program at 000h. So in the program memory, by giving this instruction db10, a byte 10 decimal value 10 is going to be stored at 000h. Next instruction is db30. So this db30 is 30h. Now hexadecimal value 30h is going to be stored at 0001h. Next comes db string. So this is now 1, 2, 3, 4, 5, 6 letters or 6 characters. So we'll be storing this string from values 002 to 007. So at 002 will be stored S, and likewise at 007 will be stored G. Next comes DB 00001111B. So this particular one is a B. That means it's a binary value. Binary value of 8 bits is 1 character. So it's going to be stored at 0000008. Next comes DB1234. This is a hexadecimal value consisting of 2 8-bit characters. So it's a 16-bit value. Now whenever we find this type of a case, we see that only one value is going to be stored. Which value is going to be stored? Is the lowest significant byte. So here it's written here, only lower byte is accepted as a DB and can be allocated only as a byte of memory. So this is going to be stored at 0009H. Next comes EQU directive. So EQU directive, one can associate a symbol or a label with a value. Like for example, throughout my program, if I want TMP to be known as to be having the value #30, so then TMP will be replaced by a value 30. Similarly, red_light will be P1.0 will be known as red_light throughout my program. Then comes the AND directive. So AND directive is one of the directive which should be used at the end of the assembly program. So once you done with the entire program, put an AND over there. So that means that no processing will be done beyond AND. Structure of 8051 microcontroller assembly language program. We'll be having label, instructions and comments. We'll straight away go to the this statement. So test label, then this is the instruction and this is the comment. So here we can see a label is followed by a colon, and then comes the instruction, then comes the comment. So comment is always written after the colon. So it's written here. So label, instruction and comments. Now instruction consists of two parts. One first part is called as the opcode and the second part is called as the operands. So in this case, move is called as the opcode and these are the operands. So the operands are, again, there are two operands in this case. So here this is a value which is called as the source operand and this one is called as the destination operand. So the meaning of this statement is to move a value 22 hexadecimal into accumulator or A register. These are some of the steps for assembling and running an 8051 program. So if we are having a assembly language program, then we have to have assembler for compiling this particular program, and once we assemble this program, if everything goes right, then we'll be generating a file called as a bin file, that is a binary file, and the hexadecimal format of this binary file is this one. So basically it zeroes down to a binary file which has to be written or burnt onto a microcontroller unit. So this particular binary file straight away can be burnt by using some EEPROM or by using some tools like flash magic and so on onto the microcontroller memory. So this is what happens. So right from writing a program using some sort of editor, then we'll use an assembler, and after assembling we'll be getting a binary file. The binary file has to be then written onto the microcontroller program memory. So that is done by using a software called as a flash magic or equivalent any other type. So these are the steps for assembling and running a program. And previously we used to make use of assembler, like this was in the olden days. Assemblers were used. Assemblers examples are A51 or ASM51. So these are the assemblers which are used for writing and compiling the 8051 microcontroller programs. So that is what the steps are given here. First is the editor. You can make use of any editor like WordPad or Notepad, and then run this assembler program on this particular file, and then if everything goes okay, then you will be generating a my file dot whatever that .alst file, then .obj file, and other object files will be also linked by using a linker program, and finally we'll be getting a ABS file, and after that will be a OH file. OH file means the hex file. Hex file is nothing but the machine file. So this was used, in the good olden days. Compilers were not widely available, so that time people used to make use of these assemblers, which are very, very simple and free to download. But now, as the program complexity has increased, we make use of high-level languages, and we make use of another environment called as integrated development environment. And there are different types of compilers which are given by different companies. One of the widely used is Kill Microvision, and the one which I am using is Kill Microvision 5. It's an evaluation version, and also we are using SIDE 51 compiler. Now, how to assemble and make a program running using Kill Microvision 5? First and foremost, we have to close all the existing project. Very important steps. Close all the existing projects. Click on a new project window. Then save it in a new folder. Select your device. Save it as simple add.c. This program I have created, so you can write your name over here. So you have to create a file, and you have to save it in some file name. So right now I have taken an example of an ASM file, so we'll have to save it as .asm. Remember one thing here, name is not so important, but this .c or .asm that we have written is very, very important. Then we have to add this file to our source file in a project. So we have to right click on the project and click and add this file to the source files. Then add the newly created file over here and go to the target options and check on create hex file. Without checking on this hex file creation, you will not be able to create the hex file. So, and finally, you can make use of the desired frequency and click on build button. So let's see these steps. So first one is, of course, we have to close all projects. So we have to click on project, and this is a kill environment, by the way. So go to project option, close projects, and then again you put new microvision project. Then next, once that is done, you are supposed to go on file menu and create a file. So create a file and give some name to that file and start typing your code. So once you type your code, your file has to be saved, and after saving that file, you have to associate this file with the source file. So for that, the step is you can right click on this and you can associate this file. You can add this file in this particular environment. Next goes to the option settings and all this. In between, I told you that we have to we have to click on create a hex file and all such things. That has to be done in between, and then finally click on the build target. Now once you click on the build target, if everything is fine, then you will be getting this particular message in the build output window. So what the message says is that creating hex file from this particular this one, so then 0 errors and 3 warnings, and build time elapsed is so much. Okay, so ignore the warnings, but only things that errors should not be there. If errors are there, your hex file will not be created. So next, as I mentioned, the hex file has been already created because everything was successful, and you will be able to see this hex file in a objects folder. So under objects, you can see the hex file. If you want to see the contents of the hex file looks like this. So it is nothing but a hexadecimal values, which are further expanded as binary codes, and they are dumped onto the microcontroller memory. Thank you.